Welcome to another episode of CHEP Codes. Today I'm going to be talking about the 4 pillars that make up object-oriented programming, which are abstraction, encapsulation, inheritance, and polymorphism. Some things to note: classes are just blueprints for objects. They define properties and methods. So you can think of the properties as the variables and the methods as something telling the variables what to do. Properties hold data. Methods contain code for behaviors. Classes abstract away implementation details. They expose the essential features. Objects are instances of classes. So for example, I am an instance of a human. They represent specific real-world entities. So an object can really be anything you can imagine. Objects contain properties with data values, and they use methods to interact. So you have to basically declare what data you want to put in that object, and then you use the method to decide what you want to do with that data inside that object, right? So back to the 4 pillars. Abstraction, just the process of simplifying complex reality by modeling classes based on the essential properties and behaviors an object should have. So it hides the complex details and shows only the necessary features of an object. And remember, in JavaScript, an object is just key value pairs, and usually looks like this right here, where you literally just have a key and a value. And the key points to basically what's the value of that object. So a quick example right here, if we're going to deal with abstraction, let's create an abstraction for a dog. So we say class dog, we'll have a constructor, which is name, age, breed, and this is saying whatever a person decides to pass it, right? So down here, when this person created a dog named Rusty, or you know what, it's actually named a dog Kobe. Rest in peace to my dog Kobe, the beef man. He was a Rottweiler. He lived to be about 10. So you see, when I create an instance of this dog class, Kobe, he's going to have his name be Kobe. And actually, I changed the name of the variable, and then I hit equal new dog, and that inside the parameters here, I have to pass it. So instead, I'm just going to call this my dog. And then see these bark things, sit, walk, comfort. See how they have parentheses right here? Well, that lets it know it's a method, and then you have the double quotes here, and you tell it what to do inside the method. So if I were to say my dog dot comfort, then we should expect in the console to be printed, I'm a computer bro, go adopt a real dog if you want someone to cuddle. But just so you can see an example of abstraction here, we create a class, we have a constructor, which we're going to pass it name, age, and breed. We'll say this dot name equals name, this dot age equals age, this dot breed equals breed, to signify whatever someone passes in the parameters. That is what that instance of a dog will have for those features. But then every single dog is going to be able to bark, sit, walk, and comfort. And if I run node abstraction, make sure I spelled this right so it actually prints to the console, we should expect it to create a new instance of a dog named Kobe, who is 10, who's a Rottweiler. And when we run mydog.comfort, we call this method. I should expect that this gets printed to the console. So let's run it and see. And sure enough, and if I wanted to tell my dog to sit, well, then I could say mydog.sit, not error, mydog.sit. There we go. And if I were to run node abstraction.js in my console again, it prints back sitting. So easy peasy. The next concept, the next pillar, is encapsulation. And encapsulation can be thought of as a protective shield that prevents the data from being accessed by the code outside the shield. It can also be thought of as a process of encapsulating something in a castle. So for example here, these methods are encapsulated in the dog class, right? And if we want to access those methods, well, we have to say my dog, because we have to access an instance of this class to access those methods using encapsulation. Another great example of encapsulation is right here. We have a car class. In the constructor, we passing in a make and a model, right? But then we have a private property. So what we're going to do is say get mileage, and it will just return whatever the mileage is. And if we want to actually set the mileage, well, then we're going to have to pass miles in the parameter. We're just going to have a simple if statement, making sure that we don't have a negative number here. So we're saying as long as miles is greater than or equal to 0, then we're going to set the mileage to whatever gets passed here in the miles. So we create an instance of a car, right? We create an object from this car class. We're going to say new car is equal to Toyota Camry. And actually, you know what? I like Jeep Wranglers. So I'll say Jeep Wrangler. So I used to have a white Jeep Wrangler in high school, and instead of having this be called my car for the variable name, I'm going to say Stormtrooper, because my Jeep in high school had a sick Stormtrooper sticker on it because it was Stormtrooper colored, which would be white with the black rims. And then we'll say Stormtrooper set mileage, and let's set it to 79 because I like that number. And then we'll say console.log, and we have to say Stormtrooper.get mileage, right? Because our variable is no longer named my car, it's named Stormtrooper. Perfect. And I just realized I spelled that wrong, so Stormtrooper. There we go. And that looks good. So right here, right, we set the mileage, and this should set it instead of 0 to 79, and then we run Stormtrooper.get mileage, so it's going to return the mileage after we have set it to 79. So hopefully you guys by now understand at least abstraction and encapsulation. And to prove it to you, let me run this in the console. And I hope I spelled that right. And we should expect 79, and sure enough, we got back 79. So if I change this to 100,000 and we run node encapsulation.js, we should get back 100,000. And sure enough, we got back 100, and that is odd. I believe it's because I actually put that comma there, and I don't need to do that. Yeah, because that confuses the computer. Would that be correct? Yes, that was the problem. I had the comma there, so it was messing it up. So yeah, that makes sense, because if I'm going to pass in an integer, the computer doesn't understand what that comma is there for. So just learn something right there if you want to cut it off early, but obviously, yeah, do not include that. So, but you guys get the basic idea. We got 2 more pillars to get through. Inheritance. Inheritance allows you to create a new class, subclass, or derived class that inherits properties and methods from an existing class, so a class that already exists, which we call the base class or the superclass. And it promotes code reusability in the creation of a hierarchical structure. And it kind of ties in a little bit with polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. It enables you to write code that can work with objects in a generic way without knowing their specific types. So I got an example right here, and it's actually inheritance as well as polymorphism. There we go. So we have a class which is for animals, and we're going to say constructor.name. So whatever we pass as a name, that'll be the name set for the instance of an animal. And every animal is going to have the speak, which basically says this animal cannot speak. And then class dog is going to, class dog extends the animal class. We're going to pass it name inbreed in the constructor. So we'll say super name because it's superseding that class. This dot breed is equal to breed. And then console.log woof, my name is this name and I am a this breed. So it'll be a dog in this case. We'll also have a cat, which extends it, and it has a super name, right? Because it's getting the name from this animal class that is a super class. But we're going to pass cat color, and then when the cat speaks, it'll say, meow, my name is whatever we name the cat, and I am whatever color we decide to pass it, cat. And if we create an array of animals, so right, we got our dog, we create an instance of a dog, and we create a new cat, and we say it's pink because a pink cat would be sick. I don't even know what color calico is. And then we can iterate over the animals and call their speak methods. So if we say for const animal of animals, because we created an array right here, right? So we're going to iterate over this array, and both these animals have this superclass, which they can get their name from because that gets passed down. But they each have their own, the dog has its breed, and when we ask the dog to speak, it'll give us exactly what breed it is, while the cat will give us exactly what color it is. So if I run node inheritance plus polymorphism, and I'm just going to copy this name so I don't misspell it. So if I type out node.js, woof, my name is Buddy and I'm a golden retriever. Meow, my name is Luna and I am a pink cat. Let me expand this a little more just so you guys can better see this. And instead, let me call him, name this dog Big Mike, and I'll say Bulldog. and I'll say solar and orange yellow. So now we should expect this to print out woof, my name is Big Mike, and I am a bulldog, and meow, my name is Solar, and I am an orange yellow cat. So let's run it again. And exactly as we expected. And now one more thing I want to show you is, let's say we create a class, what's an animal? Snake. Extends animal. And then in the constructor, we'll just have its name, right? We're not going to do anything special. We'll say super name because it's good. So we got to make sure it's coming in inheritance the same thing. And then we add this to our array of animals. So we say new snake, and then we say that's the sound snake makes, and that's going to be its name. And that's the only thing we're passing it, yes. So now we should expect it to say this animal cannot speak. And if we were to run this again, I believe we'll have that. Yep, this animal cannot speak. So if you don't assign it a speak method to override that method, then it'll just revert back to what is from the superclass. So now, hopefully by the end of this, you have a good idea of the four things, the four pillars that make up object-oriented programming. One thing I thought was really important to note, that was actually a great meme, feminist women are no objects, Java, actually. But just these ideas, these are the main takeaways. If you need to figure out how to be effective using object-oriented programming, these 5 bullet points hopefully will help you start to get a grasp on that. So again, classes are blueprints for objects. They define properties and methods. Properties hold data. Methods contain code for behaviors. Classes abstract away implementation details. They expose the essential features. Objects are instances of classes. They represent specific real-world entities. Objects contain properties with data values. They use methods to interact. So, I mean, think about how amazing the applications you can build with object-oriented programming are. When we go on Twitter, we don't think about all the stuff that's been abstracted away. We just find that excellent meme and we share it with all our friends by simply going in our camera roll, clicking on that photo, and sharing it with everyone else. And I mean, that's just one example. There's so many apps you can build out there, but hopefully you guys got a better understanding of object-oriented programming and the 4 methods that make it up. And yeah, if someone ever tells you that women are no objects, tell them that is true in real life, but when it comes to object-oriented programming, that is not the case.